I'm just kind of searching for some clues. I don't really know how I'm going to introduce the next chapter to you. It's about circles, and I'm just kind of looking for some clues. I'll even put on like a detective hat just to, I don't know, get me in the spirit of just searching for clues.
Think fast.
Ah! Okay, well, I have a basketball with a paper attached. Okay, all right, maybe this is the clue I was waiting for. I don't know. It says, what did the acorn shout when he was all grown up? Is that really a clue? I mean, what? Do you have any idea? Do you know what?
Gee, I'm a tree.
Gee, I'm a tree, like geometry. Oh, good job, good job. Okay, that's great. How does that help me with circles? Geometry. Okay, tree. I guess I need to look at trees. Okay, I'll look at some trees. Okay. Circles. All right, so I think I'm supposed to show you what to do here. I think I'm supposed to show you. It's okay, well, thanks, clue. All right, well, okay, so we've got the radii, so that's plural for radius, diameter, chord, secant, and tangent. Okay, and I'm just gonna kind of run through this. I think you probably know most of these, but a radius is a segment from the center to any point on the circle. Okay, so the obvious one right here is segment AC. All right, however, there are more, okay, because if you take from the center out to any point, there's also this one, AB, and this one, AF. All right, so we're gonna go also AB and segment AF. Easy, right? Okay, all right, so next is the diameter, okay, and as most of you know, a diameter is a segment that goes through the center, but it has two endpoints on the circle, okay, so there's actually just one diameter here, okay, and it's from point B to point F, okay, again a segment. All right, okay, so now we move on to a chord, and a chord is again a segment, and but it is a segment between any 2 points on the circle. Okay, so any 2 points on the circle. So technically this segment BF is also a chord because it's a segment between 2 points on the circle. Okay, so segment BF is a chord, but also I see another one. Do you see it too? I thought you did. Okay, so if you look here from B to C, that is technically a chord as well because it is a segment between 2 points. Okay, so segment BC is also a chord. All right, almost done here. Now we've got a secant, and a secant is a line that passes through 2 points on a circle. Okay, and so I see only 2 lines. I see one that passes through 1 point and one that passes through 2 points. Okay, and so this one right here is a secant, and this is line DE. Okay, and I'm going to back up again to chord, because if I look at this, I mean, you might look at this and think, okay, this is just a secant, but actually if you look at just the part that's between point D and point E, that's also a chord, just that piece of it. So I'm going to add one more chord, and that's segment DE. All right, and the final piece that we have on here is a tangent, and a tangent is a line that passes through just 1 point on the circle, and it's actually perpendicular to a radius in the circle. But this right here, this line is a tangent to this circle. Okay, and so I'm just going to write line, cursive lowercase letter L. Okay, because we can do that. There's not another point on the tangent, so there's no other way for me to name that. So yeah, there's some circle stuff. Not really sure what I'm supposed to do next. Maybe I'll look for some more clues. Clue. Clue! Clue. Wonder what it says. two lines with the same equation do when it rains? I know this one, and I think you know this one too. They coincide. Coincide. All right, but we're not even talking about lines with two equations. Coincide. Coincide. Go inside. I think I'm supposed to go inside, guys. Come on. Come on. Come on. Ah, here's a circle. All right, it looks like we're going to talk about arcs and angles here. Okay, so a curve on a circle is called an arc. So this arc here from A to C, it looks like this, arc AC. Okay, that's called a minor arc. Okay, but if you go the other way, the larger distance around from A to C, you grab that other point. So this arc ADC, that is called the major arc. Okay, but we're going to talk mostly about the angles. And we have two angles here. This angle ABC, that's called the central angle because the vertex is in the center. And then we have angle ADC, that's an inscribed angle. The vertex is on the circle. Okay, and if you notice, inscribed angle looks smaller than the central angle, right? Well, if you look at the central angle, its measure is equal to its arc. So that means the measure of angle ABC is equal to 50 degrees. Okay? All right. Then we are going to look at angle ADC. Okay, that's the inscribed angle. It's smaller. It's actually half of that arc. So the measure of angle ADC is equal to half of 50 or 25 degrees. Come on, Clue Fairy. Another clue. I don't know where to go from here. For real. Oh, what's this? What tool is best suited for math? What tool is best suited for math? Okay, so I don't know the answer to this one, but I'm thinking maybe we should go find a toolbox. Let's do that. Ah, the toolbox! The toolbox. There's a hammer. A couple of flashlights. Another flashlight. Flashlight. Multipliers. Pliers multiply math. Ah! Whoa. I guess this is my problem that I'm supposed to go over. You guys know that that was there all along?
Yep.
So I'm supposed to find the length of the dashed segment if we have a radius of 5 and this is 2. Okay, we will go work this out.
Oh.
All right, so here it goes. Here's the Frisbee. All right, and we're gonna find the length of that dashed segment. All right, so it shows that this radius is 5, and this little piece right here is 2. Okay, so if this radius is 5, doesn't that make this radius 5 also? Yes, good. Okay, so if this whole thing is 5 and this piece is 2, then what's this little piece right here? Yes, it would be 3 because the whole thing is 5. Excellent. Okay, so do you see anything that we can do here? A little hint. I hear The wheel's turning. Yes, we are actually going to make a right triangle right here. Okay, and I'm gonna ask you, this is the center, this is a point on the circle. So what is that called? Yes, that's a radius. So if this radius is 5 and this radius is 5, what's that radius? Also 5. Excellent. So I'm just going to draw this triangle so that all we're looking at is the triangle, so that it makes a little bit more sense here. Okay, so I'm just going to draw this right triangle. We're going to look at this right triangle. We've got 3 and 5. So we're going to find this piece. All right, and we're going to use what? Oh, I heard it, the Pythagorean theorem. Okay, and 5 is the hypotenuse, so we're going to set it up like this. We're going to go 3 squared plus this piece here, b squared equals 5 squared. Okay, so we're going to go 9 plus b squared equals 25, and then we're going to subtract our 9, and so we get b squared is equal to 16. Okay, we undo this, we get b is equal to 4. Okay, so that makes this 4 and this 4. So if we're finding the whole thing, we're just going to double that, and we're going to say that the length of this dotted segment is, that's right, it's 8. Excellent, and there's our answer. Okay, so I solved this problem, Clue Fairy. Just wondering, I mean, you seem to be helping me guide me where to go next, so where do I go next?
Wait, have you looked in the toolbox? Did you? Because you didn't really use the pliers.
You're right, I didn't use the pliers. Someone just hit me with the... So I guess I didn't really use the, thank you, the toolbox. Maybe I'll look a little bit further. Parallel lines have so much in common. Parallel lines have so much in common.
It's a shame they'll never meet.
Oh, that's true. They'll never meet. How does that help us?
It's
It's a shame they'll never
meet.
Meet. Huh. Meet. I wonder if it's like a play on words, like meat. Like, what do we do with meat? Ooh, in the summertime, we like to grill a lot. Should we check the grill?
Mm-hmm.
Let's check the grill. All right, let's go. Okay, so here's our grill. See a clue, but I do see this like cake turntable thing. I think that's something. I mean, that's the only thing I see here. And otherwise, it's just a grill. Okay, well, I guess I'll take this over here, see if I can figure something out. Cake turntable. All right. Okay, all right. Cake turntable. I just don't know what to do with this. I really wish I had like a clue right now. Come on, Clue Fairy.
Special delivery.
Oh, special delivery. All right, thank you. Let's see what we have here. We've got some baking items. Oh, I think I know what I can do with these. All right, so here it goes. So I guess what I'm supposed to talk to you about here is arcs and angles and circles. Okay, so first we're gonna look at a place where we've got some segments that cross inside of a circle. Okay, so we're looking at this. Okay, so we are going to take, for this type of problem, the rule is that basically an angle inside here, so if I wanted to find that angle right there, okay, that angle is the average of the arc measures that surround it, okay? So what I'm going to do is I'm going to take 40 plus 70 and divide it by 2 because that's the average. Okay, 40 plus 70 is 110 divided by 2. So we get 55 degrees. Okay, so our x is going to be 55. Or the measure of that angle is 55 degrees. Okay, so if we are going to find an angle measure where two segments cross inside of a circle, that angle is going to be the average of the two measures of those arcs. Okay, be careful though, because you might ask for this one. Okay, and so if you're going to find this one, you're just going to subtract from 180. So for y, we'd take 180 minus 55, and we would get 125 degrees. All right, and the next one we are going to look at is we are going to look at an angle measure when we have segments that cross outside of the circle, like this. Okay, so if we have something that looks like this, and we're going to find this angle right here, what we'll do is instead of adding the two arc measures together, we subtract them. So I am going to take 95 minus 25, and I'm going to divide that by 2. Okay, I'm going to take 95 minus 25 and divide that by 2. Okay, so 95 minus 25 is 70. 70 divided by 2 is 35 degrees. Okay, so all you have to remember is when the segments cross inside the circle, you add the measures of the arcs together and divide by 2. And when they cross outside of the circle, you subtract and divide by 2. So, I mean, I finished here. But how do I get to my next problems? What do I do? I mean, where's my clue fairy?
Look closer.
Look closer at what?
Box.
Oh. Why did Pi get its driver's license revoked? Why did Pi get its driver's license revoked? Why did Pi get its driver's license revoked? I bet it's because he couldn't stop. I bet that's it. Wait, but how does that help me? Driver's license, driver's license, driver's license. Okay, so I better check my driver's license here just to make sure it's not outdated. I just got to get it out of this little pocket here. Okay. All right. So it's not outdated, so that's good, I guess. I don't know if that's what they wanted me to do, is check my own driver's license. I'm not sure. Do you notice anything about my driver's license that I don't notice? Okay, well, what is that?
Look on the back.
The back. Ah, cartwheel. Cartwheel. Well, I promised someone that I would do a cartwheel before the end of school. So, I guess I know what I gotta do. Okay guys, so this will not be pretty. Just letting you know. This will not be pretty. Alright, here it goes. Alright, haven't done this in years. There it is, ta-da! Alright, so here it is, the cartwheel. Super great. representation, huh? So you guys know how quirky and awkward I am. So anyway, so we're gonna say that this leg or portion of me is 60 inches from here to my neck, I guess. And then I don't know how long this arm is, okay? But I know that this arm is 30 inches and this leg is 50 inches. Well, there's a rule that we can use to figure that out, okay? So here is that rule, okay? What you can do when you have segments that cross inside of a circle, now we're talking about the segment length, not the angles. We're going to multiply these two pieces together and then set them equal to these two pieces multiplied together. So A times B equals C times D. All right, so we're going to look at that and solve for X here. All right, so I'm going to say that my 30 and 50 are my A and B. So I'll say 30 times 50 equals my C and D. So 60 times X. All right, and 30 times 50 is 1500. And that's equal to 60x. We're going to divide by 60. Okay, so x is equal to 25 inches. All right, so that means that arm is 25 inches, and yeah, I'm just awkward like that. All right, there you have it.
All right, and to demonstrate one more rule, here we go.
All right, so I'm not graceful and I can't draw. So this is where we're going for the next one. Okay, so if we have, this is when I was like clapping above my head. So if we have two segments and they cross outside of the circle, we're looking at segment length again. Okay, if we have two segments that cross outside of the circle, what we do is we take, and this looks complicated, but it's not. Basically, it's the whole thing times the exterior piece, so the whole thing, A plus B, times the outside piece, B, equals the whole thing, C plus D, times the outside piece, times D. Okay, the whole thing times the outside equals the whole thing times the outside. Okay, so that's what we're going to do here. Okay, we're going to take the whole thing times the outside piece. So this whole piece is 8 plus 6, or 14. Okay, so that's my A plus B times the B, so times the outside, equals the whole thing. So this whole thing is going to be X plus 7 times the outside piece, and the outside piece in this case is 7. Okay, so I'm going to take 14 times 6, and 14 times 6 is 84, and that is going to equal 7x plus 49. Okay, and then I will subtract my 49. Okay, and I get 35 is equal to 7x, and x equals 5. Okay, so when we cross outside of the circle, we take the whole thing times the outside piece equals the whole thing times the outside piece.
Okay, and to demonstrate the final rule, it's gonna look kind of like this. No, it won't. It's gonna look kind of like this. No, it's gonna look kind of like this. I'll just show you on the board.
And the very last thing that you are going to learn in geometry, we won't even talk about how far away from this I was with whatever I was trying to do. But here is the last problem that we're going to do. Okay, this is the final rule. If you have a tangent and a segment and they meet outside of a circle, you're going to take, for the segment as secant, you're going to add the two together. So the whole thing times the outside piece again equals the tangent squared. So whole thing times outside equals tangent squared. Okay, so we're going to go with the secant. We're going to take the whole thing times the outside part. So the whole thing here is 12 plus 4, or 16, times the outside part, and the outside part is 4. Okay, and that's going to equal the tangent squared, so equal to x squared. Okay, 16 times 4 is 64, and 64 equals x squared. So then we take the square root of both of those. So x equals 8 in this case. And there we are. Last part of geometry, woohoo!
So, those are all of the circle rules that I have for you for today. And so, that's it for geometry. You guys did it! You finished geometry. So, I guess that's the last clue.
Wait! I got something. I got a clue.
You have one more clue? Okay, it says, what's a student's favorite season? What does anybody think? What's a student's favorite season? Oh, that's it! Summer! All right! Well, congratulations for making it to your favorite season. Good job making it through geometry. And I just wish I knew who my clue fairy has been, because it's been very helpful.
I guess we'll never know. Well, happy summer, everyone.